Welcome to the deep dive. Today we're setting out to explore one of the really big cosmic mysteries, the Fermi paradox. Our mission basically is to look through some fascinating articles, some research, expert views, and try to get a handle on why. Well, why we haven't found any clear signs of intelligent alien life. Especially when you consider how incredibly old and vast the universe is. It's this big contradiction. High probability of life out there versus just silence. That's what we're diving into.
And that silence, yeah, or maybe the lack of a clear signal, that really is the puzzle, isn't it? I mean, just think about it for a second. Billions upon billions of stars, countless planets where life could potentially exist, and yet nothing definite. No undeniable proof of ET. So what does this quiet out there actually mean for us, for humanity's place in it all? It's a huge question.
Okay, yeah, let's try and unpack that. The Fermi paradox. It was physicist Enrico Fermi back in 1950 who first really crystallized it, right?
Yeah.
Basically asking, where is everybody? And it gets super compelling when you grasp the scale we're talking about. I mean, just our galaxy, the Milky Way, estimates are, what, 100 to 400 billion stars?
Yeah.
That number is almost impossible to really picture.
It really is. And that scale, that sheer size and number, that's what makes the paradox bite. The SETI Institute, for instance, they've pointed out that, even with pretty modest rocket tech and, let's say, a reasonable incentive to expand, a civilization could theoretically spread across the entire galaxy in maybe just tens of millions of years.
Okay, tens of millions of years. Sounds like forever to us.
Right. But compare that to how old the galaxy is, roughly 1,000 times older, and suddenly it's like barely a blink in cosmic time.
That's a really key point.
Think it
Because
does,
humanity,
yeah.
we've only been around, 200,000 years, and actively listening for signals since 1960. That's just tiny slice of cosmic history. So yeah, if the numbers suggest life should be common, and spreading isn't that slow, cosmically speaking, where are they? It gets really interesting here. Okay, so if the universe is practically ancient and enormous, why the silence? Well, one big category of ideas suggests they are out there. We just haven't spotted them yet. Or maybe we can't. Like, for instance, the idea of radio silence. Maybe we're just in tune to the wrong frequency. That's one possibility. Or maybe, and this is kind of mind-bending, maybe advanced civilizations use communication methods we haven't even discovered. Things like neutrino beams, these particles that just zip through planets, super hard to detect. Or even quantum entanglement, this weird link between particles over vast distances.
Right. Our radio telescopes might just be completely obsolete for picking that up, like trying to catch smoke signals with a webcam. And tied into that, this idea of them being elusive, is the whole cosmic timescale problem. It suggests, civilizations might just rise and fall like waves on a cosmic ocean over billions of years. They just miss each other. Imagine countless advanced societies appearing and disappearing, totally unaware of each other. Our moment in time might just not overlap with theirs.
That's quite a lonely thought, isn't it? Cosmic ships passing in the night. But, okay, what if it's not that we can't find them, but that they don't want to be found? That leads to a whole different set of ideas. There's the famous zoo hypothesis, the idea that aliens are watching us like we're in some kind of cosmic nature preserve, and they're deliberately not interfering.
Hands-off observation, keep the primitives undisturbed sort of thing.
Yeah. And then there's the much darker take, the dark forest theory. This comes from Lou V. Sixon's science fiction novel. It basically says the universe is like a dark forest full of hidden hunters. Any civilization that makes noise, reveals itself, risks being destroyed by others who see it as a potential threat. So everyone stays silent out of fear.
It's a chilling concept, though the source material I looked at does point out it seems a bit unlikely that every single civilization, without exception, would stick to that rule, right? Someone would surely break ranks eventually.
That's a fair point. It feels like a big assumption.
And then you get into the more maybe pessimistic theories. What if something actually stops them from expanding in the first place? This brings us to the idea of the Great Filter.
Ah, yes, the Great Filter.
Right, some massive hurdle, almost impossible to overcome, that stops life or civilizations progressing. Maybe that filter is behind us, like maybe life itself or complex life or intelligence is just incredibly, incredibly rare. We were the lucky ones.
Okay. That's the optimistic view, in a weird way.
Or, and this is the unnerving part, maybe the filter is still ahead of us. Maybe advanced civilizations inevitably hit some self-destructive point. Nuclear war, climate collapse, runaway AI, some tech we haven't even imagined yet. They wipe themselves out before they can colonize the stars.
That really gives you pause. Is the biggest danger still to come for humanity? And sort of related to that is the idea of self-limiting civilizations, where societies just lose the drive to expand. Maybe they get totally absorbed in virtual worlds or focus purely on internal development rather than looking outwards.
Exactly. Which brings us to a really fascinating perspective from philosopher Wolfhart Tauchnig, published in Acta Astronautica. His argument is quite elegant, actually. He suggests intelligent life is common, but they deliberately choose not to expand.
Okay, so that hits right at a core assumption of the Fermi paradox, doesn't it?
Mm-hmm.
That spreading out is the default, the inevitable path for intelligence.
Precisely. Tauchnig argues that intelligent life has culture, and cultural evolution works much, much faster than biological evolution. These civilizations, he suggests, would likely figure out pretty quickly that endless expansion, like unchecked biological growth, leads to conflict over resources and ultimately self-destruction.
Like us figuring out nuclear weapons can wipe us all out, even though we've barely left our home planet.
Exactly that kind of realization. They develop the wisdom to survive, and maybe that wisdom involves staying put, limiting growth. And he connects this to things we see on Earth. You know, wealthier, more developed nations tend to have lower birth rates. It's a cultural shift away from maximum reproduction. For his idea to explain the silence, though, it requires that basically all advanced civilizations make this choice. If even a small fraction kept expanding like crazy, we'd likely see them.
So it has to be a near universal cultural convergence towards limitation.
That's the argument. If true, it resolves the paradox quite neatly.
So what's the takeaway here? It means the universe could be full of intelligent life, but they're all deliberately quiet and contained. We wouldn't be alone, technically, but functionally, in terms of making contact, we might as well be.
Pretty much. A universe full of neighbors who just keep to themselves.
Now, while all these ideas are really thought-provoking, some experts actually push back on the whole setup of the paradox itself. Let's bring in Professor Heidi Jo Newberg, an astrophysicist. Her view offers a different angle entirely.
Yeah, what's striking is that she says quite clearly she does not accept the premise of the Fermi paradox.
Okay, wow. So why doesn't she buy the basic premise?
Well, her reasoning really digs into the timeline here on Earth. Think about it. Simple life showed up maybe 3.5 billion years ago. Okay, a long time. But complex, multicellular life, that took maybe another 2.5 billion years to get going, so around 1 billion years ago. Then humans, us, capable of communication, only the last 200,000 years. And technology for, say, interstellar communication, radio, barely the last century, maybe a bit more if you stretch it to telegraphs, 400 years for complex signaling, maybe.
Right. So the window for communicative intelligence seems incredibly narrow in the grand scheme of things.
Exactly. Maybe the rarity isn't just life, but life that gets to the point of broadcasting signals across space and exists at the same time as us. That could be the real bottleneck.
Okay, that makes sense.
And then there are just the distances. We talk about interstellar travel, but the numbers are staggering.
Right.
Light itself takes over 4 years to get to the nearest star. Our fastest rockets, something like 20,000 miles per hour, would take, what, 33,000 years to get there?
33,000 years, just to the neighbor.
Yeah. And to the center of our own galaxy, light takes 30,000 years. That same rocket would need 170 million years. Maybe spreading across the galaxy, like Fermi assumed might be easy, is actually vastly harder or slower, or maybe even practically impossible for biological life forms or their machines as we understand physics now.
That really changes the calculation. It deflates the expectation of seeing galactic empires everywhere. And, this actually lines up with a shift we're seeing in how scientists are searching now. Instead of just Drake equation style, how many communicating civilizations? Many are using things like the Seeger equation, which focuses more on just finding any signs of life, like biosignatures in atmospheres, stuff like widespread photosynthesis changing a planet's air. It's less about finding ET radio hosts, more about finding alien microbes or plants first.
That's a great point. It broadens the search dramatically. And Newberg uses this analogy I liked. Imagine 6 tons of sand, billions of grains. You might think, surely one of those grains must be uranium, right? But no, uranium dissolves in water. It wouldn't likely be there as a grain. Just because you have a huge number of planets doesn't automatically mean every possibility, especially complex ones like communicative intelligence, must exist on some of them.
Right. The sheer number doesn't guarantee the specific outcome we're looking for. So the current focus is more fundamental. How many planets are there? What are their conditions? Is there liquid water? Can we detect atmospheric signs of any life?
Yeah, build the foundation first. Get the statistics on life itself, then worry about whether it's building radio telescopes.
Okay, so wrapping this all together.
Yeah.
Why should you, listening right now, care about the Fermi paradox? It seems pretty abstract.
Well, it actually has some pretty profound implications for us, for humanity's future, especially this idea of the great filter.
Ray, is it? Behind us or ahead of us?
Exactly. If the filter's behind us, if life, or complex life, or intelligence is just vanishingly rare, then wow, maybe we are special. Maybe we're among the first, maybe even the only ones in our galaxy right now. That carries a certain responsibility,
The
perhaps.
responsibility to survive, maybe.
Perhaps. But if the filter is ahead of us, if advanced civilizations tend to destroy themselves, then the silence isn't comforting. It's a warning sign. Our
Yeah.
own long-term survival is definitely not
It's
guaranteed.
sobering. So
Yeah.
the search goes on, right?
Oh, great.
With better tools.
Absolutely. We have amazing instruments now, like the James Webb Space Telescope, actually sniffing the atmospheres of exoplanets, looking for those biosignatures. And we have advanced AI helping to sift through signals, looking for patterns humans might miss. The search is getting more sophisticated all the time.
It feels like we're chipping away at the possibilities.
We are. And honestly, whether we eventually find evidence of aliens or we confirm as much as possible that we are truly alone, either answer is going to fundamentally change how we see ourselves and our place in the cosmos.
It forces you to think about what it means to be human in this vast universe.
Definitely.
So we've journeyed through this huge question today, the Fermi paradox. We've looked at explanations ranging from, aliens hiding from us or maybe just being too quiet,
To the idea that advanced cultures choose not to expand. Or maybe that communicative intelligence is just incredibly rare or fleeting.
or that the whole premise of rapid expansion might be flawed. It's a lot of ground covered.
It really is. And that great silence, as it's sometimes called, it really does remain one of the biggest mysteries out there. Are we alone? Or is something distance, time, choice, or maybe danger keeping us from hearing anyone else? The question is wide open. It pushes us to keep looking, keep wondering.
And if you want to keep wondering and dive even deeper after this, we definitely recommend Stephen Webb's book, If the Universe is Teeming with Aliens, Where is Everybody? It lays out like 75 different potential solutions.
Yeah, it's very comprehensive. And the Wait But Why article on the Fermi paradox is fantastic too. Really breaks it down visually.
Oh, good one. And of course, the SETI Institute's website is always worth checking for the latest news and research.
Definitely. Lots to explore.
Absolutely. Well, thank you for joining us on this deep dive into the cosmic quiet.